Good afternoon, everybody. So today's our topic is directly. I will go to topic. Our topic is special theory of relativity. In this Lorentz transformations and its applications, first we should learn. So we should learn what is special theory of relativity. In this special theory of relativity, there is a two frames. The first one is inertial frame and the second one is non-inertial frame. The frames in which Newton law base, that frame is called inertial frame. Already we know that. So reverse process, the frame in which Newton laws doesn't obey, that frame is called non-inertial frame. In this special theory of relativity, which can be explained by the Einstein. So first, what are the principle of special theory of relativity? The basic law of physics are the same in all inertial frames. The basic law of physics are the same in all inertial frames. That is, all inertial frames are equivalent. First, Galileo explains Galileo transformations. Here, Galileo transformations is nothing but like this. First, let us take two inertial frames. The first one is S and the second one is S dash. These are the inertial frames. Consider two reference frames S and S dash, which is as shown in figure. S dash is moving in x direction with respect to the S. Let a point P, the coordinates of P with respect to the S, that is x, y, z, t, and with respect to S dash, that is x dash, y dash, z dash, and t dash. So relation between these two coordinates, we can write the first one is x equals to x dash plus vt. Already in diagram, the x equals to x dash plus vt. Then we can write x dash equals to x minus vt. So in x direction there is a change, that is x dash equals to x minus vt. But there is no relative motion along y and z directions. That's why we can write y dash equals to same as is y and z dash equals to z. And also time is independent of space coordinate system. Hence we can write t dash equals also t. So these four equations, x dash, 1 and second, these equations are called Galileo transformations. X dash equals to x minus vt, y dash equals to y, z dash equals to z, and t dash equals to t. So these are the Galileo transformations. Only Galileo transformation explains the low velocity of frames, but the high velocity similarly equals to light velocity. The Lorentz transformations can be explained. These Lorentz transformations explains by the postulates of special theory of relativity, which can invention by the Albert Einstein. So what are the postulates of special theory of relativity? Very, very important points. 2 points. Already I explained. The first point is all physical properties are same in all frames. All physical laws are the same in all inertial frames, which are moving with a constant velocity relative to each other. And the second point is the speed of light, velocity of light in vacuum is the same in each and every inertial frame. These are the two main important points. The first point is all physical laws are invariant in all inertial frames which are moving with a constant velocity. And the second one is the speed of light in a vacuum is the same in all inertial reference frames. So these are the postulates of special theory of relativity. So from these two equations we can learn Lorentz transformations of space and time. This one is very important question. Lorentz transformations of space and time. What are the Lorentz transformations? The Lorentz transformations are x dash equals to the first one, this one, x dash equals to x minus vt by under root of 1 minus v square by c square. The second one is t dash equals to t minus vx by c square by same as this denominator under root of 1 minus v square by c square. This one is second Lorentz transformations. And y dash equals to y, z dash equals to z are invariant, same as this. These four, first, second, four are the Lorentz transformations. These Lorentz transformations explained by this diagram. Let us consider two inertial frames S and H dash, which are S dash is moving with the velocity of v with respect to the S in a positive x direction. The coordinates of a point P is x dash x, y, z, t, and from h dash x dash, y dash, z dash, t dash. So next we can write here c square equals to this one, c square t square equals to x square plus y square plus z square. Then by using special theory of relativity, what is the first point? The first point is x dash, physical properties are invariant, that is x dash equals to some constant k into x dash. Here x dash equals to some constant k into x minus vt. This one is first equation. What is the first equation? First equation is x dash equals to k into x minus vt. So by using special theory of relativity, here by using special theory of relativity, the first special theory of relativity is nothing but x equals to ct, and already we know that x dash equals to ct dash. Substituting these equations in 1, so we can get ct dash equals to k into ct minus vt. Simplifying this equation, we can get k value. What is the k value? K value here 1 by under root of 1 minus v square by c square. So substituting equation 7, so this one is equation 7. So substituting equation 7 in equation 1, what is the first equation? First equation is nothing but x dash equals to k into x minus vt. So substituting k value in x dash, we can get x dash equals to x minus vt by under root of 1 minus v square by c square. This one is called first Lorentz transformation. So next derive second Lorentz transformation, that is dividing c on both sides of above equation, that is x dash by c equals to x minus vt by c into under root of 1 minus v square by c square. So simplifying these equations, so we can get t dash equals to t t minus vx by c square by under root of 1 minus v square by c square. This is a second Lorentz transformation. These are the two Lorentz transformations. The first one is this one. The first one is x dash equals to x minus vt by under root of 1 minus v square by c square, and the second one is t dash equals to t minus vx by c square by under root of 1 minus v square by c square. So these are the Lorentz transformations. Once again I can repeat. Lorentz transformations for high velocity frames. You can use Lorentz transformations by using this frame. This first one is S frame and the second one is dash frame. S dash frame is moving with v velocity with respect to the frame of S in positive x direction. There is a point, pulse point, light point P. So the coordinates of P equals to with respect to x, xyz, and with respect to h dash, x dash, y dash, z dash, and t dash. Relation between these two, we can write c square t square equals to x square plus y square plus z square. So the first equation, by using first special theory of relativity, we can write first equation x dash equals to k into x minus vt. This one is first equation. From the second equation we can write x equals to ct, x dash equals to ct dash. Substituting x and x dash values in first equation, we can get substituting 3 and 4 in first equation, we can get fifth equation, and also simplifying we can get sixth equation. So simplifying these equations, we can get k value. So k value equals to, what is the k value here? K value equals to seventh equation. So k value equals to 1 by under root of 1 minus v square by c square. By using seventh equation and substituting seventh equation 1, we can get this equation, that is x dash equals to x minus vt by under root of 1 minus v square by c square. Okay, so this is first Lorentz transformations. Dividing with c on both sides. Next one, dividing with c on both sides of first equation, we can get x dash by c equals x minus vt by c into under root of 1 minus v square by c square. Simplifying these equations, already we know that distance by velocity equals to time. In a s dash, that is t dash. X dash by c equals to t dash, and x by c equals to t. Substituting these values in above equation, we can get a second Lorentz transformation, that is t dash equals to t minus vx by c square by under root of 1 minus v square by c square. These are called Lorentz transformations used for high velocity frames. There are two applications in Lorentz transformations. The first one is length contraction, and second one is time dilation. By using these Lorentz transformations, there are two applications. The first one is length contraction, and the second one is time dilation. Okay, next we should learn next question, very important question, Einstein mass energy equation. That is, what is the Einstein mass energy equation? E equals to mc square. This one is Einstein mass energy equation. E equals to mc square. So we can find out Einstein mass energy equation by using Einstein mass energy equation. So derivation of Einstein Einstein mass energy relation, that is, already we know that the variation of the mass with the velocity is given by first equation. Variation of the mass with velocity that is m equals to m naught by under root of 1 minus v square by c square. Square on both sides. Here SOBS is nothing but square on both sides. So then square on both sides, we can write m square equals to m naught square by 1 minus v square by c square. So m square equals to m naught square, simplifying above equation we can get m square equals m naught square by c square minus v square. So simplifying on above equation we can get m square c square minus m by m square v square equals to m naught square c square. And differentiating, so c square here UV process, differentiating on both sides, so we can get a second equation, that is c square dm equals to mv dv plus v square dm. Already we know that according to Newton's second law, F equals to change in momentum, that equals to d by dt of p, and also we know that p equals to mv. So substituting F equals to p equals to mv in F, we can get F equals to m into dv by dt plus v into dm by dt. This one is third equation. When a particle is placed through a distance dx by the application, then the force is applicable. So then the kinetic energy can be written as dk equals f into dx. Substituting fourth equation and third equation, we can get a dk equals to m into the value of f, substituting in fourth equation we can get dk equals to m into dv by dt plus v into dm by dt into x. So substituting these values we can get dk value mv dv plus v square dm, and second equation is equals to the fifth equation. Hence equalizing these two equations, dk equals to c square dm, on integrating on both sides, then we can get integral of dk equals to integral of c square dm. So k equals to c square into m minus m naught. Here k equals to mc square minus m naught c square. Already we know that total energy E equals to ke plus pe. So here p equals to m naught c square. So E equals m naught c square plus k. So then E equals to mc square. So this one is Einstein mass energy equation. So this equation is called Einstein mass energy equation. Okay, so this one E equals to derivation of E equals to mc square. Can I repeat again? This question will be repeated. So the first Einstein mass energy equation. First, we know that relation between mass and velocity in a variation, that is m equals to m naught by under root of 1 minus v square by c square. Square on both sides, we can get m square equals to m naught square by 1 minus v square by c square. Simplifying this equation, we can get m square c square equals minus m square and v square equals to m naught square c square. So differentiating on both sides. So here there is a UV process, and also m naught is a constant value, hence this becomes 0. So m square is nothing but 2m into dm into c square minus v square into 2m into dm. So here c is nothing but constant value, so hence here is 0. So simplifying of this equation, we can get a second equation. That second equation is c square dm equals to mv dv plus v square dm. So let us, according to Newton's second law, what is Newton's second law? F equals to ma, either F equals to dp by dt. So substituting dp p equals to mv value in f, we can get f equals m into dv by dt plus v into dm by dt. That one is third equation. When a particle is displaced through a distance dx by the application of force F, then the increase in kinetic energy, because of there is a motion. So motional energy is nothing but kinetic energy. So kinetic energy is given by dk equals to F into dx. Substituting equation 3 in equation 4, we can get fifth equation, that is dk equals to mv dv plus v square dm. Already second equation is equals to fifth equation. So equalizing these two second and fifth equations, we can get dk equals to c square into dm. On integrating on both sides, so integral of dk equals to integral of c square dm. Then k equals to c square into m minus m naught, that equals to mc square minus m naught c square. But potential energy is nothing but m naught c square. So then substituting these two equations in total energy, E equals K plus P, we got E equals to mc square. This is Einstein mass energy relation. What is Einstein mass energy relation? That is E equals to mc square. So this one is Einstein mass energy equation. Okay, so the next concept is the final concept in this chapter, 4 vector formula. Simplification of calculation of vectors in special theory of relativity, we can use 4 vector formula. What is 4 vector formula? 4 vector formula is nothing but in the form of matrix formula. This one is 4 vector formula. So here x1 dash, x2 dash, x3 dash, x4 dash. So this one is 4 vector formula, that is gamma 0 0 I beta gamma 0 1 0 0 0 0 1 0 minus I beta gamma 0 0 gamma x1 x2 x3 x4. This one is 4 vector formalism. You can derive 4 vector formalism. Let us consider two reference frames, S and S dash. Already we know that S is constant and S dash is moving with constant velocity with respect to S. Let an event represented by x, y, z, t and x dash, y dash, z dash, t dash with respect to the frames of S and S dash. Let us consider electromagnetic wave generated out of the flash in the both electromagnetic travels with the speeds in all directions in frame S and S dash. Hence we can write speed c with the time, then x square plus y square plus z square equals to c square t square. And also we can write x square plus y square plus z square minus c square t square equals to 0 in S frame. In x dash frame, we can write x1 square x dash square plus y dash square plus z dash square minus c square t dash square. From equation 1 and 2, there is a two equations are equal equations. Why? Because there is invariant in physical property by using first postulates of special theory of relativity, that is x square plus y square plus z square minus c square t square equals to x dash square plus y dash square plus z dash square minus c square t dash square. According to Lagrange invariant, the quantity has same value in both x square plus y square plus z square minus c square t square equals to x mu square. Here in general x, y, z are the three coordinates. There is a possible of treated fourth coordinate, that one is x4. Here x4 is nothing but ICT. The length of the vector is given by, so x1 square plus x2 square plus x2 is nothing but summation of x3 square. So here x equals to x1, y equals to x2, z equals to x3, and time can be in the form of virtual form, that is x4 equals to ICT. According to Lorentz transformations, x dash equals to x minus vt by under root of 1 minus v square by c square, y dash equals to y, z dash equals to z, and the fourth one t dash equals to t minus vx by c square by under root of 1 minus v square by c square. Substituting x1, x2, x3, x4 or xyz values in above equation, we can get x dash equals to x minus v into, whereas t equals to x4 by ic by under root of 1 minus v square by c square, y dash equals to y, z dash equals to z, and ic t dash equals to ic into t minus vx by c square by under root of 1 minus v square by c square. Substituting and simplifying in these values, we can get x1 dash equals to x1 plus vx ivx4 by c by under root of 1 minus v square by c square. x2 dash is nothing but y dash, that equals to y. x3 dash is nothing but z dash, that equals to z, and x4 dash is nothing but t dash in the form of t dash ict. x4 is nothing but ict. We can write x4 minus vx ivx by c under root of 1 minus v square by c square. So here let us assume 1 by under root of 1 minus v square by c square is nothing but gamma, and also v by c is nothing but beta. Substituting these are gamma and beta in above all equations, x1 dash, x2 dash, x3 dash, x4 dash, these are the becomes in a form of matrix equation. So x1 dash equals to gamma x1 plus there is no x2 x3, that's why we can write 0 plus 0 plus I beta gamma x4. x2 dash equals to only we have x2, so 0, x1 term 0, x2 term 0, and x2 term is a magnification of 1, and x3 is a 0, x4 also 0. In x3 dash equals to 0 plus 0 plus x3 plus 0. x4 dash equals to gamma into x4 dash equals to gamma into x4 minus I beta x1, that is minus I beta into gamma x1 plus 0 0 plus gamma x4. So by using these four equations, we can write in the form of matrix form, that is x1 dash, x2 dash, x3 dash, x1 dash, x2 dash, x3 dash, x4 dash equals to gamma 0 0 I beta gamma 0 1 0 0 0 0 1 0 minus I beta gamma 0 0 gamma. This one is 4 vector formalism. Why we are using 4 vector formalism? Simplification of vector mathematical vectors in a special theory of relativity, or in general physics we are using 4 vector formalism, that is x1 dash, x2 dash, x3 dash, x4 dash equals to gamma 0 0 I beta gamma 0 1 0 0 0 0 1 0 minus I beta gamma 0 0 gamma x1 x2 x3 x4. These are the 4 vector formalism. So this is special theory of relativity. This one is special theory of relativity, inertial frames, non-inertial frames. What are the inertial frames? Inertial frames. What are the inertial frames? Inertial frames which can obey Newton laws is called inertial frame. Which can't obey Newton laws is called non-inertial frames. By the special theory of relativity, there is 2 postulates. The first one is physical quantity or physical property in all inertial frames is invariant, and the second one is speed of the light in all inertial frames there is a constant value. So these are the 2 postulates of special theory of relativity which can be invented by the Albert Einstein by using inertial frames. And there is a Galileo Transformations, x dash equals x minus vt, y dash equals y, z dash equals z, and t dash equals to t. But these Galileo transformations uses only small velocity, but for high velocity, that is equivalent to light velocity, we are using Lorentz transformations. The Lorentz transformations are x dash equals to x minus vt by under root of 1 minus v square by c square, and t dash equals to t minus vx by c square by under root of 1 minus v square by c square. So by using these Lorentz transformations, there is two applications. There are two applications. The first one is length contraction, and the second one is time dilation. So next, Einstein mass energy equation, that is E equals to mc square. We derived already by using m equals to m naught by under root of 1 minus v square by c square. So finally we got Einstein mass energy equation, E equals to mc square. Okay, this one is Einstein mass energy equation. Finally we got Einstein mass energy equation, E equals to mc square. Next, 4 vector formula, x1 dash, x2 dash, x3 dash, and x4 dash in the form of matrix form, that is gamma 00 I beta gamma 0100 001 0010 minus I beta gamma 00 gamma of x1, x2, x3, x4. This 4 vector formula is uses in complication of mathematical vectors, simplifying in special theory of relativity. So these are the main key points and the main important questions in special theory of relativity for long and short questions in semester 1. For the first year students got good results in special theory of relativity. Why? Because special theory of relativity is a very good chapter, and compulsorily there is a 2 long questions and 3 short questions from this special theory of relativity. So one should learn Lorentz transformations and their applications, Einstein mass energy equation or relation, and the finally 4 vector formula. Okay, so these questions are very important in semester exams and also competitive exams like PG entrance exams, HC entrance exams. In competitive exams, there is a very important topic is special theory of relativity. Okay, so this one is స్పెషల్ థియరీ ఆఫ్ రిలేటివిటీ. సో కంపల్సరీగా ఖచ్చితంగా డామ్ షూర్గా వచ్చేటటువంటి క్వశ్చన్ ఐన్స్టీన్ మాస్ ఎనర్జీ రిలేషన్ అండ్ దెన్ లారెంట్ ట్రాన్స్ఫర్మేషన్స్ అండ్ అప్లికేషన్స్ 4 వెక్టర్ ఫార్ములిజం కూడా అడిగే ఛాన్స్ ఉంటుంది. కాంపిటేటివ్ ఎగ్జామ్లో అయినప్పటికీ కూడా, అదేవిధంగా సెమిస్టర్లో అయినప్పటికీ కూడా, దేంట్లో అయినప్పటికీ కూడా ఈ చాప్టర్ అనేది చాలా ఇంపార్టెంట్. సో ఇన్ మోడర్న్ ఫిజిక్స్ లాగా